Welcome back, friends and students. So today we are going to start a new situation in which I'm going to discuss some of the questions from the qualitative analysis, like I posted my previous video related to the chemistry 9701 practical exams, in which I in detail discussed that how many different type of the practicals we have. And now today I'm going to solve some of the questions that will show you that how you are going to solve different questions in your practical exam. So welcome back on Wellstand Chemistry Tutorials, and today, as I described, we are going to discuss some of the questions related to the practical exam. So the first question I'm going to discuss, it is about the qualitative analysis. So what is qualitative analysis? We are going to discuss in detail, and to understand this properly, I am going to discuss one question from an exam from the recent papers, that is 9701 May-June 2022. Okay, so if you have any question related to the question which I'm going to discuss, you can ask me directly on my WhatsApp number or on the comment section. Then if you have still some question and confusion and you want some one-to-one interaction, then you may also contact me. So now going back towards the target, and I'm going to discuss some of the questions. You can see this is Cambridge Assessment International Education, that is Cambridge International AS and A level, and you can see the paper is 970133 and it's from May-June 2022. So now the first question, that is usually, as I previously discussed in my videos, that it is related to the titration, and you can see this is related to the qualitative analysis. You have to read this paragraph carefully, and while you are performing your practical exams, please try to understand properly. Okay, and it is more important that while you are practicing, you have to read all of the instructions carefully, and when you are in exam, you must have to save your times, and this could be helpful when you read all of the instructions, and when you are doing your real exam, it will be really helpful. Okay, so straightforward, going to the question, in which it says that acid donates protons. We know the Bronsted-Lowry theory of the acid and bases, that proton donors are always acids. So it also says that proton donor is an acid in aqueous solution. The number of moles of hydrogen ion donated per mole of acid is the proticity of the acid. In this experiment, you will carry out a titration to determine the proticity of phosphoric acid. The formula of the phosphoric acid is H3PO4 when it reacts with aqueous sodium hydroxide, NaOH. So this is the situation. Fa1 is the sample 1 solution that is given to you in your exams, and the bottle definitely labeled as Fa1. Then Fa2, Fa3. In the both bottles where these labels are present, there might not be some of the concentration or other information related names. It's straightforward written as Fa1, Fa2 and Fa3. So please focus and just try to deal with all these chemicals like Fa1, Fa2 and Fa3. Now, as concerned for the method, you have to read it carefully and do as directed. Please focus, and I'm repeating, do as directed. Whatever is directed in your exam, try to solve this and try to do this. In first situation, he says that fill the burette with Fa2. So first of all, consider in your burette, so you have to take out your burette and try to fix it on the burette stand with the help of burette clamp carefully. Okay, so this could be the type of a burette where you have, and there must be some readings, and you must have to know that what is the maximum or minimum error that could be done, or that is the potential this equipment has, this apparatus has. So what is the error? Remember, the gap between the two minimum readings is considered as the error. So keep that also in mind, and then carefully fill this burette up, okay, using the glass funnel. Now place the glass funnel, and first of all close this tab. Must close this tab, okay. Then start filling the solution carefully. It is advisable try not to fill till 0.00. Why? It will require more attention and it may cost some time. So whatever the reading is, easily you can fill it up. Please fill it up that. And like if you filled it up like this portion, now this could be called as the initial reading. This could be called as what? Initial reading. Understood? So if you fill it up till 0, this is more important, and this could be easy. It could not be easy. Okay, so in time or in your paper, time is more precious while you are focusing on 0.00. so it will require maybe sometime you add some more or some less. So try not to do this. Just fill it up where it is easily filled, and then try to note that reading as an initial reading. Secondly, the second instruction says that pipette 25.0 centimeter cube of Fa1 in a conical flask. You have to take your conical flask. Now use the pipette. First of all, you remember you are given by the pipette. The shape of the pipette could be like this. If you are never ever into the chemistry lab, and you don't know what is the pipette, so it is the help. The shape of the pipette could be like this, and there is only one mark. There is only one mark on that pipette. Okay, so remember there should be one mark only. So now here it is clearly written the total capacity of the pipette. This is 25.0, and here must be some value given which shows that what is the percentage error or the chances of error in this pipette. Use also a pipette filler. Remember, pipette never ever used singly. It should be always paired up using the pipette filler. Okay, carefully fill it up, and if you never ever goes and measured any volume using the pipette, please then try not to waste your time. Just focus and easily, whatever the situation is, try to fill it up and transfer the 25 centimeter cube of the solution of Fa1 using the pipette into the flask. After that, use the dropper, which is definitely be given from Fa3. Add few drops. When there is the word few drops, try not to add more than 3 drops. Okay, try not to add more than 3 drops. Or if there is clear instructions that how many drops requires, then you have to follow that instruction. So after that, this is simply related to some practical procedure. Now after the practical procedure, it is more important to present your data properly. So now read this instruction. It says that perform a rough titration and record your burette reading in the space below. Please remember, never ever present your data without a table. Always try to present your data in the form of a table. And for titration, there is a fixed pattern that will help you to note down the readings. Okay, what is the pattern? Always try to write volume, or even you can say final volume of the burette, and always try to write the final volume first. Final volume, or even you can say reading. Instead of the volume, you also say final reading of burette. And remember, put the unit as well in cm cube. The final reading is always in centimeter cube. Then note down initial reading, of burette /cm cube, and then at the end you must have to note volume used, and here, as I said, if you are measuring first time, then you could say that your reading was 0 initially, but as I said, making it 0 little difficult, it will take time. So try not to make it till 0. Whatever the situation is, try to fill it up easily and then take that reading as initial. Like in this case, I am considering the initial reading is let 8.70. okay, and second more important thing is, whenever you are writing the reading of the burette, try to use it till 2 decimal place. This is more important, till 2 decimal place. After that, then you have to note down, sorry, this was the final, I have to write it as initial, that is 8.70. now the final reading, like roughly I'm going to say, wait a minute, I'm going to my calculator back. Where is my calculator? Okay, roughly I'm going to take it is like 2033.50. so now you have to find the difference. What is the difference? It should be 0, 15 to 7, it is 8, and then 12 to 8, it is 4 and 2, so it is 24.80. And remember, as I'm not performing the practical, so these are the reading just based on the rough values, but you have to focus whatever the reading you got in your titration, follow those readings. Okay, always try to follow only those readings which are according to your practical work. And moreover, then if you are unable to find any reading, then please stick to the format like I did it by your mind roughly, or if you have some idea from left to right, then get that idea, but you will awarded marks according to the format here I'm mentioning. Okay, so please follow this pattern, you will successfully earn marks. There is a chance that you may lose the mark, that is due to the accuracy, and accuracy is the exact result whichever the examiner is expecting, and he performed the experiment and he got the results. If your results are differ from his results, then there should be a chance you will not be able to get the accuracy mark. Okay, but remember that the accuracy mark, for that sake you are not going to ruin your whole of the experiment and your exam. Okay, so all other marks will be awarded, just there is a chance that accuracy mark will not be awarded. So try not to bother for that, try to focus on the pattern. Then he says that carry out as many accurate titration. So first of all, now we have to discuss what is accuracy. So remember, whenever you are going to do titration, and in your titration if there is a gap of 2.00 between two readings, and then you have to make a titration, another titration that should be there is a gap of 1.00, then you say that you are doing more accurate readings. So keeping this point in mind, you have to draw and you have to perform as many experiments. But at the same time, when you are doing many experiments, it will cost time. So in your exam, your exam is time oriented, time limited, so you have very less time. So please try not to perform any other experiment, just perform 1 or 2 readings. Okay, just perform 1 or 2 experiment and then straightforward follow this format: final, initial, volume used. And after that there is one more reading which we can say that this is the reading, or we can say best titration results. So there are 4 readings. First of all, you have to say final, burette reading, slash cm cube, then initial burette reading, and slash cm cube, then you have to say volume used slash cm cube, and then finally you can say best titration results, best titration results, okay, in cm cube. Sorry, as these we are going to just select them, so not unit required. Here I'm going to say the after this, please remember this situation in your mind and then try to write down all the readings. Now this time say the final initial reading is 0.00. This makes that easier to draw and note down the volume. Here again I'm going to say 0.00. This was the rough titration. Now you have to write another titration with the difference of maximum 2, and then gap of 1. So here we can say 23.1, sorry, 0.1, not 2.0 here. Please focus here, I mistakenly write it 1 and 2, but remember 1 and 2, but 0.1, 0.2 and 0.1. So when you do this, so this should be 24.60, and here the gap of 1, 24.50. What should be the final results? Remains the same as the initial reading was 0. Sorry, so it should be 24.60 and it should be 24.50, and these two results should be considered as the best titration results. I'm going to place the tick. Remember, the gap between these two readings should be 0.1. So all those readings which have this gap should be considered as accurate readings. Okay, after that, and you can see there are 7 marks. 1 mark is the pattern, like you are going to mention your results in the form of a table. Second, for writing this format, the final, the initial and volume used. Third mark will be awarded to the units which you mentioned in centimeter cube. Fourth mark should be awarded to the pattern of the readings. Like I said, write down the readings of the burette always into decimal places. Okay. The fifth mark is between the gaps. The value should be in a regular and the proper pattern, and rest of the 2 marks are related to the accuracy. Now, if your reading is not matching with the reading of the examiner which he got during the performance of the practical, then there is a chance you may not get these marks. Otherwise, all of the marks will be awarded. Okay. So if you know the practical performance, please do it very carefully so that these accuracy marks may not be deducted. Otherwise, if you don't know, then no need to focus for that. Try to focus to get all the 5 to 6 marks which are not related to the accuracy. Then proceeding in this part, he says that from your accurate titration result, clearly mention from your accurate. As I said, these two are the accurate results. I'm going to say like 24.60. Now we are going to get the average value, so 24.50 and dividing it by 2 to get the average value. So this should be 24.55 centimeter cube. The unit is already mentioned, so no need to mention the units. Okay. Now moving on to the next part, then he says that calculate the amount in moles of sodium hydroxide present in the volume of Fa2. As we calculated, the volume of Fa2 we used was 24.55, and while we are going to convert the volume and having the concentration and we want to find the moles, we are going to use the formula N means mole equals to concentration or volume times concentration. Here is the volume. Now we have to look forward for the concentration of Fa2, which was already provided and given. You can see the concentration of Fa2 was 0.15. Okay, so focusing for that and using that value, we can have to multiply it by the concentration, which is 0.150. Now remember, while we are applying this formula, we must have to convert the volume which was in centimeter cube to decimeter cube. For this purpose, we are going to divide it by 1000. Okay, in this way we will get the moles. Now I required calculator, but I couldn't found. Please hold on, I'm going to get my calculator back. Okay, sorry boys and girls, now I have my calculator back, so going to divide and get the exact values. This is 24.55 divided by 1000 and then multiply by 0.150. So the answer I got, it is 3.68 times 10 raised to the power minus 3. And as you already noticed, the moles is written, so no need to mention the unit. You just have to write down this value over here. Now keep moving. Next situation, next question is, use the information on page 2 as we found it, and we use the concentration of the page 2. This is the information. So examiner is talking about this information, so I'm going to use this information. Keep that. What is the concentration of the acid? Sorry, not here, this is page 2. Yes, here he says, yes, this is the information. Okay, 6.86 and other information as well, 6.86. keep that in mind, please. Now he says, use the information on page 2 to calculate the amount in mole of phosphoric acid present in 25 centimeter cube of Fa1. Again, we are going to use the formula N equals to C concentration times V volume. As the volume is clearly mentioned, which is 25.0, so I'm going to say 25.0 divided by 1000 to convert the centimeter cube back into dm cube. Now we need concentration, as the value given was 6.86, but it was gram per dm cube. So remember, whenever this is the concentration as well, but this concentration is in grams, and we want to convert this concentration from gram to mole per dm cube. Okay, as in this formula the concentration is always in mole per dm cube. So to divide this gram per dm cube into mole per dm cube, just divide by the mr of the compound. So the mr of phosphoric acid, mr of the phosphoric acid, remember it is 98. You may calculate it by your own. So if we divide this value, which is 6.86 divided by 98, so I got 0.07. so the concentration is 0.07. now we have to multiply this value with 25 divided by 1000. So then I got a value of 1.75 times 10 raised to the power minus 3. 10 raised to the power minus 3. So here you have to write this value. Then he says that deduce whether phosphoric acid behaves as a monoprotic, diprotic or triprotic. So now, boys and girls, we have two values. We have the moles of phosphoric acid and we have the moles of sodium hydroxide, which are reacting with each other. Now the value of the sodium hydroxide we calculated was 3.8 3.68 times 10 raised to the power minus 3, whereas the moles of the phosphoric acid we calculated was 1.75 times 10 raised to the power minus 3. So what we have to do now, remember, when we have the moles, we can convert these moles into the simplified whole ratio. How? By dividing with the smaller value among these two. So as this value is the smallest, so 1.75 times 10 raised to the power minus 3 and 1.75 times 10 raised to the power minus 3. So this will give us 1, whereas this value, I'm going to check it, 3.68 times 10 raised to the power minus 3. Here it is, minus 3, and then we have to divide it by 1.75 times 10 raised to the power minus 3. Okay, so when we divide it, we will get 2.10, that is approximately equals to 2. So this will give us the idea that phosphoric acid and sodium hydroxide both are reacting with 1:2. So whenever we have 1 mole of the phosphoric acid, we requires 2 mole of the sodium hydroxide. It clearly means that sodium hydroxide contains, remember, OH ions. So how many 2OH ions will be there in 2 moles of the NaOH? 2. So how many protons are reacting from the phosphoric acid? So definitely 2, so that there should be complete neutralization. So in this case, we can and we clearly say that how many protons are released by the phosphoric acid in this specific questions that are reacting with the sodium hydroxide. So we can say there are 2 protons, and this information we obtain from the molar ratios, and this is exactly our explanation. Okay, so either now you may write this in your words, or if you show this working, this could be considered as your explanation. Now just write one sentence that as the ratio of phosphoric acid to sodium hydroxide is 1:2, indicates that the 2 protons of the acid are reacting with 2 moles of the hydroxide. Understood? So this should be the explanation, or either this working should be considered as the explanation of this answer. Hopefully you understand. Now proceeding towards the next part, then he says that give equation for this reaction. It says clearly this reaction. We don't know, we know that phosphoric acid is behaving like triprotic acid, but according to the calculation and the experiment performed, it clearly revealed that now phosphoric acid is only releasing 2 of hydrogen ions. So as the ratio we obtained, we must have to balance the equation according to this situation, 2 moles and 1 mole. So when they react together, and remember, phosphoric acid is behaving as a diprotic, so the formula for the salt we get should be Na2HPO4. 2 of hydrogen from the phosphoric acid gone, whereas only 1 is left, and water. Now you have to balance, and as I said, the equation should be balanced using only these molar ratios. No other values could be used, okay? Otherwise it could not be balanced. So now you can see and you can check the equation is balanced or not. For this purpose we only have to place 2 over here, the rest of the equation is balanced. Now proceeding next, okay, in D part, a student uses a pipette that is labeled 25.0 plus minus 0.06. so remember, this is the possible error. This is what? Possible error in measuring the volume by using this label pipette, which is provided in this exam or according to the theoretical part. Then he says that calculate maximum percentage error. So remember how we gonna find this percentage error. So the formula is the error, which is 0.06 into the times how many times we use the pipette for measuring that volume. So we know that we use the pipette only once, okay. Then divided by total volume which we used to measure using this apparatus, which was 25. Now as we are going to find the percentage, so you have to multiply it by 100 to get it convert it into percentage. So the answer is 0.06 divided by 25 multiplied by 100, and the answer is 0.24%. 0.24%. So the maximum error that could be there in measuring the 25 centimeter cube of the volume using the pipette, which has this error capacity, is 0.24%. okay. Then he says that the student suggests it would be more accurate to measure the volume of FA1 with a burette instead of the pipette. So now we are going to find the error of the burette using the same technique, using the same method. So here you can see what is the maximum error in the burette. As I earlier said in this video, in the start of the video, that for finding the error you have to focus what are the minimum reading of that apparatus. So remember, the minimum reading of the apparatus is 0.05. The burette can measure the minimum value of 0.05, and we use the burette 2 times while reading, as we mentioned in our tables that the final and the initial volumes, so mean we are using the burette 2 times, okay. Then to measure the same or single volume, so what volume we were expecting to measure is 25, and as we are going to find the percentage, so we have to multiply it by 100. Now I have to calculate again. So what is the value? It is 0.05 multiplied by 2 and divided by 25, and then whole multiply by 100. So the answer is 0.4%. 0.4%. So which is clearly more than 0.24%. So clearly mentioned the percentage error increases. What it means, you should consider which should be more accurate. So we can say, he said the question was students suggest it would be more accurate. No, it is not more accurate because the percentage error increases, okay. So we can say student is wrong, incorrect. It is incorrect. State whether you agree. No, we are not agree. Okay, it's clear, not agreed. Why? As percentage error increases from 0.24% to 0.40%. This should be your answer. And hopefully, boys and girls, you understand what was the procedure to perform the titration and how to calculate the relative, theoretical and calculation based questions. So now again, if you have any question related to this video, you may ask, okay, any question, whatever the question you have. And if you want to get some more detail or chapter review or anything you want, so you may contact me on my number, plus you may ask questions if you have in the comment section. So stay tuned. I will try to be continuously posting new videos specifically related to your practical exams, as most of you people are struggling with this. Okay, so take care for this, and we will see, and I will upload new video soon. Take care. Bye bye.